Okay, quick look through the 2021 applied maths paper. And the idea here, I'll just try and go through some of the method behind it and supplement some of the really crappy solutions given by the SEC, where they try and give you as minimum information as possible and somewhat reluctantly give you a solution that's dragged out of them. So okay, so let's have an overview of it. First of all, I think the question one, motion can be a bit of a curb dog sometimes, but this one was okay, I think. So ball thrown vertically downwards, and then the car passing by. In terms of cars passing by each other, this one was okay, I think. Ball thrown vertically downwards, that was a good lead-in question, fairly straightforward, I'd say. So a ball reached half the building in 1.2 and then further 0.8 to reach the bottom of the building. So it's taking shorter to reach the second half because of acceleration. It's speeding up. Find the value of h and the speed of the ball. So that's fairly okay. Main thing there is just you don't know u. So with all these things, you can see you're given 2 times. So you know you're going to get 2 equations. You're going to have 2 simultaneous equations with 2 unknowns, and you can solve. So, but the main thing is you don't want to drag another one in. So you don't know u. So it's good to start from the start at each time. So the first one, you're going to take v is equal to u plus at for half the building. So after traveling, you say it's gone half the height after t equals 1 or 1.2. So we'll say far more useful would be s equals ut plus half at squared. So that means h over 2 is equal to 1.2 u, which you don't know yet, plus g over 2 1.2 squared. Grand. So one equation, 2 unknowns there, so you need another one, and then the second half of the building. Now the key is the second half of the building, you don't know this, so keep the same starting time. You don't want to have brand new u, so let's start at the start. So I'm going to say the time, so for the full lot of the building, so we're going to start at the start and get to the bottom this time, and that's h. So t then will be equal to 1.2 plus 0.8, which is equal to 2 to go a distance of the full height of the building. So height is equal to 2u plus g over 2 squared. So that's really the only thing you just have to watch there. Now you'd probably get away with it if you did it in different segments, but that's just the only thing. So you start up here at t is equal to 0, t is equal to 1.2, it's halfway down, so that's the first equation. And for the second equation, we're just taking the full length of the building, rather than, because if you started here, you've another initial u, so you'd have to call it u2 or something, and you don't know that, and you don't know the original ones. So if you start at the same time each time, you're dealing with the same u each time, so just one unknown. And that is fairly trivial. So just 2 simultaneous equations, 2 equations, 2 unknowns. Just solve for h in this case. The speed of the ball then at the bottom of the building, well, v is equal to u plus at. You know, gravity, time, you know the full time. You need v, and you don't know u yet. But you have 2 equations and 2 unknowns up here. So you've solved for h, and you can also solve that for u, so you can get it out of those equations. So you get h and u arising out of solving those equations, so that will give you a u, and then you can find your speed. So that's grand. Car C moving uniform acceleration 2 seconds later, and then they pass point Q together. Okay, given a lot of information there. So you saw they pass P and then they pass Q. So let's put in all the information, given quite a bit. With speed, okay, so C, and the diagram is fairly useful here. Acceleration, speed, U and F, D, 2 seconds later, so let's just put t minus 2 in the same direction with uniform acceleration, 2f. We don't know the initial speed of ud. We don't know that. We expect that. Oh, we do. Okay, so 6 over 5u. 6 over 5u, right? So we know quite a bit. And then they pass point q together. So speed of c, so v here, 6.5, and v, d is equal to 9. You're given so much information, it's important to give the right variables and subscripts to them just to keep track of it. Should it see travels from the, yeah, okay, so you know they travel the same distance, so the same distance formula will work for them. So s equals ut plus a half at squared. So apply that for p, and you get s is equal to, what time is it? You're not given a time, eh? Yeah, okay, so yeah, maybe v is better, yeah, because you have v. Okay, so let's start at v. So vc is equal to u plus at. So that gives me u plus 2, no, not 2, plus ft is equal to 6.5. Next one is 6 over 5u plus f to t minus 2 is equal to 9. Two equations, two unknowns. We'll be able to find t out of that. So the time for them to meet. Great, we have that. Should also give you f as well. Okay, so, and then show the travels in how many length of time. Yeah, so that's giving it t. So you can solve that for t and also solve for f. Yeah, so that's pretty straightforward. So two simultaneous equations, two unknowns, and it pops out. So that's underlying all these applied maths questions are they're all going to boil down simultaneous equations in the end. Okay, so question 2, relative velocity. Two lads meeting. Okay, so this guy, yeah, so find the value of t, the time taken, and also the angle that b has to go to. Okay, well, with all these, the crucial one in relative velocity is drawing the triangle. And the key is whether to draw a velocity triangle or a distance triangle. And in this case, they've given you a nice distance there, so it kind of lends itself to drawing a distance triangle. 45, you're given a lot of information there, so that's nice. So it starts to run in a straight line, Alan runs, so Alan is doing a good job at running at 2.5 there. And B waits 8 seconds. So Alan has the run on this guy, so 2.5, and he's got 8 seconds ahead of of Slowman. Hi Siobhan.